radius of this, let it be R1. Then there's another solenoid. The radius of that, let that be R2. And now the current, here current is 2I. Here the current is I. So there's a solenoid 1, solenoid 2. What about the B bar produced by both the solenoids? In what direction be? Will be into the plane? Into the plane. So everywhere the B bar, and we have here charge particle. He himself is telling it's going to move in a circular path of radius r. And there's a charge particle. Get into the problem now. Increase linearly with the time. So the current increases linearly with the time. So let me take I is equal to KT. 2 KTB. Magnetic flux. So now what will happen to the induced electric field here? B bar due to both will be into the plane. No? So how the induced electric field should act at this particular point should be, I'll bring charge exactly at this point. It'll be easy for us to show tangentially. This will be E bar. So how to calculate that E? E is what? Induced electric field. We should calculate that flux linking, no? Now, what about flux linking the, like in a region of radius r, the first solenoid, where all it can produce the field. So if you are getting confusion, do take help of superposition of both the fields. Do take superposition of both the fields. So first, only one solenoid you take. It's solenoid 1 with a black color ring. I'm showing it. So where all it produce field, only inside it, no? So what is the expression for B1? What do you write? Mu naught N. What is the current? High, it should be 2 KT. And then what is the flux linking till here? Flux due to the first solenoid should be equal to B1 into effective area. Effective area is pi R1 square only. No? Because where is R? R is here. R is here. So there's the point P, I'll write it. So is it okay? B1 effective area pi B1 into pi R1 square you're going to write. Now let's come for draw a blue color line. Now where is the point P? Point P lies inside this solenoid. This is R2, radius R2. This is R1. Yeah. Pi R1 square. And where is that trajectory of charge particle? Will lie inside here. This should be R, and there's the point P. Now what is the flux linking it? First calculate So what is the current? Current is what? I is equal to KT. And how it will produce B bar? B bar everywhere it will be blue color one. Now write it. What is the flux linking it? Flux linking due to this second solenoid. Phi 2 should be equal to effective area pi r square only. There it was pi r1 square. Try to notice. The point P lies outside this solenoid, but B bar is confined only to circular region of 0 to capital R1. Here the B bar is confined to the circular region from 0 to capital R2. But we want till only the effective area is pi r square. So pi r square into dB2 by dt. So this should be equal to how much? Mu naught n k. Okay, so we are not integrating, no? Differentiating. Keep it here. Mu naught n kt. Now, when both are present, what you are going to do? The total flux linking now in a circular region, in a path, there's a path of radius r. The total flux should be equal to phi 1 plus phi 2. So add up these two. So this will be mu naught n 2 kt pi r1 square mu naught n mu naught n kt. I'll take outside pi. So 2r1 square plus r square. So whenever more than one solenoid comes, you take help of superposition principle. Then differentiate this, will get the EMF induced. Then we can go for induced electric field. Before that, I think there's only flux, no? So therefore, what is induced electric field? E into 2 pi r. And I'll start with the definition. It'll be much easier. E into dr. Dr is this one. E into dr, this should be equal to d phi by dt. Everything I took care in S dB by dt, everything I taken care in the calculation of flux only. So now what is EDR? So this should be E into 2 pi r is equal to mu naught n k to r1 square plus r square. Pi get cancelled, so 2 will end up there. So the expression for E will be mu naught nk by 2r to r1 square plus r square. This is the expression for E. Now the particle there, what happened, will experience a tangential force. And let's come to the question. At the rate of increasing current in solenoids, a charged particle initially at rest between solenoids starts moving along a circular path of radius r. How it is possible? Magnetic force, what it will do? B bar, and it's having a tangential velocity. So the magnetic force will start acting in this direction. Right equation, no? So that will provide required centripetal force. What about tangential velocity? How to calculate tangential velocity? Look at E, constant or variable. Look at this value of E. It's a constant, no? So therefore, what is A tangential? I'll go back to circular motion. Non-uniform circular motion should be QE by M. Then what is the speed of the particle at any time? So this should be equal to A tangential into T. Then this magnetic force will provide required centripetal force. So this should be equal to QVBM. Or go back to circular motion concept. This, what about the B there? You have to calculate B due to at that particular point. How to calculate B? Magnetic field due to outside solenoid, and all that B has to be calculated now. So one V will get cancelled. Able to link this one? The magnetic force here, Lorentz force will provide required centripetal force. I'm equating the condition mv square r equal to qvb. So here, what is the value of B? We don't know B, no? There, how to get the magnitude of magnetic field strength?
U0 and KT.
Only due to external solenoid only it should be there, no? The magnitude there. Then substitute that. So I think here we'll do one thing. First we'll take it out. This much here. Mu naught n kt. This should be equal to m r v, what you can write as qe by m into t. So the t also get cancelled, and you know value phi. Substituting that e here, solving, will get the required answer. So I'll give the answer.
2 root 2.
2 root 2.
Yes, sir.
Yeah. Some application problems. So now just keep in mind, like in a region where magnetic field is varying, induced electric field is set up. That induced electric field, what it will do? It will make the particle to accelerate. It will keep the particle in equilibrium. It will keep the particle to move in circular path. So many conditions will come for you. You must be ready for that one. I substituted V is equal to QE by M, QET by, so here substitute the value of E from here, this equation, and solve it, you'll get the required answer. So that mu n, mu naught nk will get eliminated, you can see from here. Okay, let's take the next one. Yeah.